Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to my panels, TS Zulkarnain bin Marjub, and the second panel, TS Encik Muhammad Harezul bin Osman. Today I would like to present the Bachelor Degree Project 2 on development of dual side vacuum block for vacuum clamping system. Before I explain the detail of my project, let me briefly introduce myself. My name is Muhammad Harezul bin Abdul Razak with a metric number B0717106109. I have been supervised by TS Dr. Nufariza binti Abdul Wahab. This is a presentation outline. Firstly is introduction that consists of a problem statement, objective, scope of project, and I will go to the literature review, methodology, result and discussion, and the last one is conclusion and recommendation. Introduction to a vacuum clamp. In manufacturing system, fixture and clamps are an important part of the material removal process. The vacuum clamp is one of the fixtures used widely in the manufacturing industry. The vacuum clamping technology provides to ensure no damage when using this clamp system with any of the scratches or clamping marks on workpiece. Third, the vacuum clamping concept is typically used primarily in the whole of workpiece or flat surface product. For this project, the method and design that develop a vacuum block is in upper and lower dual side vacuum block. Problem statement that I found from previous project, it found that the vacuum block is not suitable as the portable vacuum block because heavy to bring. Solid Delrin is used for previous vacuum clamping block. The uncontrolled flatness of vacuum clamping block surface for previous project had made the holding tin material has a little bit warping down on the middle of a vacuum block. Third, design analysis made during previous project focused on strength of vacuum pressure only. Meanwhile, in this project, more emphasis on two considerations, which is weight itself and the strength of a vacuum suction. My objective of this project is, first is to design the dual side vacuum blocks using SolidWorks software. Second, to study structural static analysis on dual side vacuum blocks by using SolidWorks static analysis software. Third, to fabricate dual side vacuum blocks by using selective laser sintering and CNC machine respectively. Scope of this project. Firstly is the research project will focus primarily on static structural of dual-side vacuum blocks based on effect of a force component by two material consists of Delrin and a polyamide material. Second, the dual-side vacuum block design will be drafted by SolidWorks software. Third, design of dual-side vacuum blocks will be analyzed using SolidWorks structural static analysis. Fourth, polyamide and Delrin is used in this project as a material to develop the dual-side vacuum block. Fifth, the dual-side vacuum block will be fabricated using a selective laser sintering and CNC machining. And sixth, after that, dual-side vacuum blocks will be measured by observe its functionality. For the literature review, this is a portable vacuum clamping that carried out by the previous student cohort 6. Cohort 5. Portable vacuum clamping, the tool which mechanical elements that usually used to clamp workpiece in a milling machine. The method consists in development and optimization of the vacuum clamping in milling machine. The vacuum clamping design will be then developed. Portable means the vacuum clamping machining process for each part completely using milling machine and CNC milling machine. A second literature review is a single self-contained dual-side vacuum clamping that carried out by a student cohort 6. This literature review for a basic theory of SLS manufacturing machine. Selective laser sintering SLS for the powder bed fusion family is an additive manufacturing technique. The laser selective sinters polymer powder particles, fuses and form a layer by layer component throughout SLS. Thermoplastic polymers are in a granular form the material used in the SLS. Okay, for this literature review, telling us about a condition of a pressure. This vacuum clamping system was carried out by a student cohort 6, which is a pressure in method. Pressure in is air pressure come from directly from compressor to a vacuum system. Second is without pressure in. Without pressure in is no air pressure from a compressor directly because without pressure in have a pressure suction system to support the suction. Okay, for this literature review, this telling us about a thrust force obtained from a milling pocketing process, which is use a pressure in method and a without pressure in method. For the project flowchart, it will start from literature review, and I will give it into two. First is design vacuum block Delrin, and second is design vacuum block polyamide. And both of these material will go through a static analysis, and the bond misses, stress, strain, displacement of these both material will be obtained, and the Delrin material will proceed to the computer-aided manufacturing CAM process of a Delrin vacuum block, and a polyamide. I will go through the fabrication of polyamide vacuum block, and both of these vacuum block will go through a mechanical structural test. If the material of the vacuum block meet the requirement, it will proceed to discussion, and if not meet the requirement, the vacuum block will also go to the end. Design. The design are created by SolidWorks software, which SolidWorks can draw in a 3D part file and interpret it become 2D drawing file. This is a design of dual side vacuum block for both material, which is the lean material and the polyamide material. Analysis simulation. Then the part file will be generated for the static structural study. The generated properties in a SolidWorks software will allow you to choose which is the best design of a dual side vacuum block. Assign material properties to the model. Using the SolidWorks simulation material dialog, add a material and build or modify the material. In the material dialog, you can specify a source, a material model, and material properties by use of the properties tab. In the study, the daily material or the scientific name polyoxymethylene, form, and polyamide PA are chosen with some properties such as tensile strength, compressive strength, yield strength, mass density, and etc. Whereas to run the simulation. Applying fixture. In this study, the fixed geometry is selected by using a square face fixture. Applying external load. Load are stresses and pressure applied on the model face and edges and vertices. The model will be applied a uniform and a variable force, pressure, torque, bearing loads, body force, including gravity and centrifugal force in the SolidWorks simulation. This is input parameter and will be set up into the force applied on the surface of a dual side vacuum clamping. This is a selected area for the force applied. After we apply the force or load, we meshing the model. Mesh control enable models for component faces, edges, and vertices to define a number of size elements depending on the geometry and dimension of the models, element size, mesh tolerance, mesh control, and context specification, the size of the mesh generated, number of nodes and element, which the element size 5 mm and 0.5 mesh tolerance, the measure ultimate 301576 nodes and 19275 elements. Generating result. The main study of static analysis is generating report. After the model has been meshed, model will be run to define the study result such as stress plot, strain plot, displacement plot, and the safety of factor. This is the result of the generating report. Hollow Delrin vacuum block is in a static analysis simulation. It will be changed to the solid Delrin vacuum block in static analysis simulation. Okay, you can look at the result and discussion for the change reason. Fabrication of Delrin vacuum block using CNC. The 5-axis CNC machine is used for the development of this innovation of dual side vacuum block. This is a flow diagram of a CAM process for Delrin vacuum block using a Catia software. Firstly is a conversion of a file format, and I will go to the preparation to the computer aided manufacturing, and third is a tool selection and a part operation, and lastly is a CAM machining process. Conversion of file. Once the 3D dual side vacuum block design has been completed in a SolidWorks, the part design will be exported CAD design to a CAM compatible file like a step or IGES. Before proceeding to the CAM preparation, the part design will be briefly analyzed either the part geometry meets the requirement of Catia CAM or not. If the part design does not fulfill the requirement, it needs to redesign in a SolidWorks. Preparation to a computer aided manufacturing. In preparation to computer aided manufacturing, we must do a stock making, exit system, plane system, and assembly. Both of these, among of these three, stock making, exit system, and a plane system. Tool selection and a part operation. The manufacturing process initiates a new part operation and adds a part operational entity to the tree. The dialog box for the part process is revealed. Select one from the machine until part. Then the progress is proceed to the tool selection. Suitable tools have been selected for the machining process. CAM machining process. In this research, advanced machining workbench is used as the main interface to generate the movement of cutting for 3 or 5 axis machining, and the machining process applied in this study are pocket, facing, and hole drilling. Fabrication of a polyamide vacuum block using SLS machine. In this study, selective laser sintering printing is an additive manufacturing technology that uses a laser to sinter powder plastic material into a solid structure based on a 3D model design. Okay, next, the functionality test on a polyamide and the lean vacuum block. The polyamide vacuum block and the hollow Delrin and the solid Delrin vacuum block will be tested on the functionality. A polyamide vacuum block is tested by clamping the wood board with a 20 kilo weight, and a solid Delrin vacuum block is tested by clamping the wood board with a 20 kilo weight. Result and discussion. Comparison table of a static analysis. This table is created in the static analysis to differentiate each static structural properties between two materials. The best material will be chosen for the vacuum block fabrication. This is a comparison result of a static analysis between a hollow polyamide vacuum block and hollow Delrin vacuum block. you can see the indicator bar, which is the stress obtained from the hollow Delrin vacuum block is lower than the stress that obtained from a hollow polyamide vacuum block. This strain same likely as a stress between a hollow polyamide and hollow Delrin. This displacement, we can see the displacement is not too different. Discussion of static analysis test. In addition, for this, both vacuum clamping block meet the acceptable range within the stress strain value under the yield strength value. The displacement for both testimony is out of an acceptable range. Therefore, these two vacuum blocks are not supposed to choose for use as clamping. Then we proceed it and we plus one of the design, which is the solid Delrin. We compare in terms of displacement. Displacement of the solid Delrin vacuum block is show the value is lower than both of the hollow vacuum block. This graph of a static analysis, when the graph is thoroughly defined, the line of hollow SLS or polymer overlap the line of hollow Delrin vacuum block. This because value of static analysis for both vacuum block is quite same. Result fabrication of polyamide vacuum block using as SLS machine. This is a top view, side view, and a front view. This is a result fabrication of Delrin vacuum block using CNC machine. Result of functionality test on a polyamide and Delrin vacuum block. The dial gauge pressure show that, for the hollow polyamide vacuum block, the dial gauge pressure show that the vacuum pressure is slowly dropped from the setting pressure, which is 70 kilopascal, goes down to 47 kilopascal and slightly goes down to 0 kilopascal during machining. And the solid Delrin vacuum block, the dial gauge pressure show that the vacuum pressure is very slowly dropped from the setting pressure, which is from 70 kilopascal goes down to 69.2 kilopascal and keep maintained until the pressure closed. This is hollow polyamide and Delrin vacuum block in the static analysis simulation. Not acceptable due to the out of functionality test, and I will proceed to the solid Delrin vacuum block in a static analysis simulation. Discussion of functionality result. After the functionality test was carried out, the result can conclude that the hollow polyamide vacuum block is not acceptable. This is due to the structure of the hollow polyamide vacuum block getting warpage on one of two sides of vacuum block surface. So the only vacuum block to proceed for use as a machining clamp is solid vacuum block. Conclusion. As conclusion, desired design of a dual side vacuum block can be developed by using SolidWorks software. Furthermore, static analysis study in a SolidWorks software is used to establish optimal stress strain that vacuum block can withstand towards force of cutting tool. Also, from the static analysis study, the displacement of the vacuum block can be determined as a vacuum block present going to failure. Recommendation for this project: the smoothness of a vacuum block surface is very important that need to consider for improving the high accuracy of pocketing process performance. To keep maintaining the vacuum pressure, so the surface of a vacuum block should be flat, so that the vacuum pressure will not going down and keep suck the machining part. The depth dimension has potential for significantly increase the accuracy. Okay, Okay, thank you. That's all for today's presentation. Also, thank you for the panelists that are listening to my presentation.